All right, so we're going to answer this question before us. It says that we need to consider the function this and state a largest possible restricted domain of f of x such that the inverse exists. Okay, the first thing that we need to do is just to be able to picture this in our head, and we should be able to do this immediately. We should be able to recognize that this is a quadratic in turning point form, meaning that it's been shifted 3 to the left and 2 up. So that means it's going 3 this way, it's going 2 up. It looks like that. That is what the graph looks like. You need to immediately be able to recognize that. Now, as it currently exists, I would not have an inverse function for this function here, and it's because it doesn't pass the one-to-one test, or it doesn't pass the horizontal line test, therefore it is not one-to-one. I therefore need to state a largest possible restricted domain of f of x such that it is one-to-one, because if it is one-to-one, then the inverse will exist. In order for it to be the largest as possible, I'm going to have to restrict it from the turning point. That's what I'm going to have to do. So what do I mean by this? That means that I'm only going to consider either this part of the graph or this part of the graph, but not both. So for this one, I'm just going to consider this part of the graph, but you could do either one. As it says, state a largest possible domain. There are two options here. You could have either chosen this part or this part of the graph. It doesn't matter, but let's just choose this part of it. So that means what my answer here is going to be is the x is an element of, now it's going to be negative infinity all the way to negative 3, including it. That's going to be the largest possible restricted domain. For it to be the largest possible, I have to include negative 3, because if I didn't include it, it could have been bigger. So there we go. So as it currently is restricted, it is now one-to-one. So the inverse is going to exist, and because I've cut it at the turning point, it is the largest possible domain. But remember, we could have chosen the other side, meaning, we're not going to do this, but meaning we could have said it is from negative 3 to infinity, and that would be including that side of it. I'm not going to go through that in this video, but at the very end, I'll show you what the working out would look like. But for this video, I'm just going to work through this scenario here. We then continue. It says, using the restricted domain of A, find the equation. So we're finding the equation of the inverse, stating the inverse in the form of the function notation. Okay, so what I need to do is I need to take my original graph, which is y is equal to x plus 3 squared plus 2. I now am going to find the inverse. What do we do to find the inverse? You swap your x and your y around. We go x minus 2 is equal to y plus 3 squared. We then square root both sides. Remember, we're going to get plus or minus. We then subtract 3 from both sides. Minus 3 plus or minus the square root of x minus 2 is equal to y. Now, this is where you need to be careful, because it can't be both positive and negative. I'm going to write that in. Can't be both. You need to figure out whether or not it's going to be positive or negative, but it can't be both. Let's just picture this for a minute. If I come up here, and if I was to draw both the positive and negative version of this, it would look like this. Does that look like the inverse of this? No, it doesn't look like the inverse of the red part there. It's either going to be just the positive part of the square root or the negative part of the square root. Either this part or that part, but not both. So how can we figure out which part it's going to be? You can immediately see that the turning point here, or the endpoint of the square root graph, is going to be, now if this point here is, if I zoom in here for a second, if this is negative 3, 2, that means that this point here will be 2, negative 3, because we're just swapping them around. This will be 2, negative 3. Remember, the x and y's swap at that point. All right, if we continue, we need to figure out whether or not it's going to be the positive or the negative of this. To do that, you consider your domain of the original function and the range of the original function. So the domain of f, we know, because we defined it, is negative infinity to negative 3 inclusive, and the range of it is, now the range can be seen by our little sketch that we did above here. It's going to be 2 to infinity. 2 to infinity like that, because it's going from 2 up. And now from that, we can figure out what the domain of the inverse will be and the range of the inverse. All right, the domain of the inverse is simply going to be the range of the function. So it's going to be from 2 to infinity. And the range of the inverse will simply be the domain of the function. So it will be negative infinity to negative 3 inclusive. Take note, the range is from negative infinity and it stops at negative 3, meaning I'm just considering the bottom part of the graph here. So that means writing it in full function notation here, the inverse function is going to have a domain of 2 to infinity, a codomain of all real numbers. Remember, the codomain is always all real numbers. And then from there, I can say, all right, what am I doing next? I'm going to go, this is that, negative 3 minus the square root of x minus 2. I didn't say plus or minus, I just said the minus there. And that is going to be my answer. I have written it down. Perfect. We now move on to the next part. It says we now need to sketch it. Now we've already done a rough little sketch to help us out through this question, but now we need to formally sketch it. We know that this one, so negative 3 to 2, this point here, it says I need to label the endpoints. So I need to label them with coordinates like that. And it needs to be a closed circle as well. And then I need to sketch this. Now, you could do this in a couple of different ways. You could just say, well, I know that the endpoint is just going to have the x and y switched. So this will be 2, this will be negative 3, it will be there. And I know it's the bottom part of the graph. So therefore, and it's important to label these as well. This is the inverse. And the black one is the original. Label this as 2, negative 3, and I'm done. There are no x-intercepts here, and it says axial intercepts, if they exist, they don't exist in this case. Also take note that we could have drawn the inverse just by looking here. This is saying shift it 2 to the right, shift it 3 down, and this negative is saying just take the negative part of it. But that's how you would approach this question here, very similar to what you saw in the textbook when doing these things. Now, just before we move on, remember at the very beginning, it says state a largest possible domain to restrict it, and we said this was just one of the options. The other way to do it would have been to restrict it so that you've got the other side of the graph. So that means it would look like this orange part here. And if you did that, that means that the inverse would actually have the positive part of the square root, the positive part of the square root right there. And if you did it this way, you'd actually end up with axial intercepts, which you would then have to solve. So I'll just zoom out here if you want to have a closer look. I'll pause it and look there. But yeah, that's how you would approach it. Also take note of the mark schemes here. Whoopsie daisy. You got 1 mark for this one, 3 marks for that one. 3 marks. Where would the 3 marks be allocated? Most likely 1 method mark, 1 mark for saying the correct domain, and then 1 mark for saying the correct inverse function there. And then 2 marks here. So obviously 1 mark for this, 1 mark for that, making sure you're labeling the endpoint and axial intercepts. All right. Hopefully you're successful with this question, and I'll see you in the next part.